about these radicals is this. If the radical has an even index, it is required that underneath we only have positive or 0, and the answer has to be positive or 0. However, if the index is odd, positive, 0, negative, positive, 0, negative. In other words, what I'm saying, when the index is odd, you have no worries. When the index is even, you have two worries. One, that the quantity under the square root or fourth root or sixth root is greater than or equal to 0. 8 minus 7x must be greater than or equal to 0. You solve the inequality, and that's your domain. But when the index is odd, because the index is even, I have to write this. If the index were 3 or 5 or 7, I would have not written anything, just the domain is all real numbers. Now I have to move 8 to the other side, because we know how to, why am I saying 8? It's 4. It's just because I said 8. So we move 8 to the other side, we divide by -7, and we have to flip the inequality symbol. We know how to solve linear inequalities. So -7, x greater than or equal to -8, so x is less than or equal to 8/7. In interval notation, we have from -infinity to 8/7. Now, it depends on how they want the answer. And let's read. The domain of this. Simplify. Type your answer in interval notation. So I will have to write a parenthesis and then a bracket. And then inside I will write infinity with minus, of course. And then a comma, and then 8/7. 8 divided by 7. And that is a domain. Type your answer in interval notation, use integers or fractions for any numbers, la, la, la. And that's all we needed to do.
Oh my goodness. So when you take it to 0 and you pretty much flip the side of the numbers, put it on the other side of the greater than or whatever, it flips the side of the...
When we divide or multiply, when we divide or multiply both sides of an inequality by a negative number, we have to flip the symbol.
Okay, I didn't get the negative infinity on the right side. So. Or infinity, I did positive infinity. So.
I see. Every time we multiply or divide an inequality, both sides of an inequality, by negative numbers, we have to switch the inequality symbol.
Okay, thank you.
Because it's not valid anymore. Good. Other questions? Anything else from anything else?
That's all I got, unless someone else has some.
Anybody else? Other questions? So we have to go practice some more with this domain. That's where we stopped last time. And then continue. Anything else? Anybody? Okay. Let's work on more. That's exactly where we stopped. That's exactly where we stopped. I just need to plug in my laptop. Okay. Good. So let's look at other domain. So let's say f of x equals the square root of 2x plus 28. So let's take a minute and determine the domain for this function. And then I would like to evaluate it at 4. I'm putting in the attendance. That's what you're hearing. So I don't forget. Good. Done. Okay. So can anyone give us the starting point for the domain?
Negative 25 over 2.
So 28x, 2x plus 28 must be greater than or equal to 0. We move 28.
That's 28? Oh, okay. My bad.
No worries. So then 2x greater than or equal to negative 28 and x greater than or equal to negative 14. So therefore the domain of this function is from negative 14 to infinity. Now here's, yes, you can do this by hand, but let's also look at the calculator. I highly recommend in y equals, enter the function as is, be careful how. So you have the square root. Let me turn that off. Okay, so we have the square root, and that's 2x plus 28. I prefer parentheses. I don't know what type of calculator you have, but some calculators pop up with parentheses already. So we have the function in the graphing calculator, and second and table, I just plug in 4. I know what the answer is. 4 times 2 is 8. 28 plus 8 is 36. So the answer has to be 6. And I get 6. So you can always determine or check your answers. But please put it in the graphing calculator in y equals. So the answer is 6. Good. Any questions on this problem? Any questions on this problem, please? What about the domain on this function, the cube root of 2x minus 4? How do I determine the domain of this function? Anyone can give us a hint on the domain of this function? Anybody, please say something.
2 to infinity?
Why?
Negative 4 gets moved over to positive 4 divided by 2 is 2.
What did we say about the cube root? What did we say about the cube root? What is the domain of the cube root?
All real numbers.
That's it. I have nothing to write. No conditions, no solving, no nothing. Why? Give me any number. I'll plug it in, I'll give you an answer. So let's do that. So you can
16.
see. Okay, so we want to, in y equals, clear everything. And the cube root, what is the power on the cube root? We need to know that by now.
3?
No, power 3 and the cube root are not the same. Any radical is an exponential notation with what type of power? If it's an integer, it's not a radical. If the power is an integer, it cannot be a radical. So the cube root is power. Which power?
Two.
It cannot be an integer. 2 is an integer.
1/3.
Aha! Thank you. Indeed, the cube root is power 1/3. Excellent. And now you wanted me to evaluate it for anything. Just give me any numbers you want. Let's say negative 2000. Let's say 0. Let's say 500. Let's say 22. Let's say anything you want. But if I add another function here, let's say the square root of x plus 1, I can no longer the calculator would scream at me at some of those numbers. Let's see. Look at how it's screaming. It's screaming at negative 2000 because the square root does not exist if the radicand is negative. Okay? It gives me all the answers I want for the cube root, but not for the square root. So if I put here negative 300, it's going to scream again. Error. Because the domain of the second function is 1 to infinity, negative 1 to infinity. But the domain of the first function is just anything you can dream of. Anything. Because it's the cube root. Cube root have no restrictions. Cube roots have no restrictions. Okay? Moving on. What if we're asked to graph, let's say, f of x equals the square root of x minus 7? So let's review the simplest possible square root function. The simplest possible is the square root of x. And you have to remember the graph. It's very important. And now we have the square root of x minus 7. How will I graph the square root of x minus 7?
You go down 7.
Excellent. We go down 7 units. 1, 2, 3, 4, 5, 6, 7. That's it. So this is the square root of x minus 7. Very good. Any questions? Okay. Now, the last section sections of this course deal with other methods of solving quadratic equations. So we have to work on that. And then we will review for test 4 on Thursday. So, other methods of solving quadratic equations. What do I mean by other? Which one do we know already? Anybody remembers? Which method we already know? And we studied and we studied and we studied of solving quadratic equations. Anybody? Anybody remembers the first one that we studied?
This is one of the chapters I definitely have to study, so nope.
Factoring, right? We already know that. We can factor and solve using the zero product principle. That was done a long time ago. Now we're going to look at 3 other methods. So this was done. If it's factorable, I don't know. If it's not factorable, then I cannot use it. Second method is taking square roots. So let's work on this one, and then we move on to the third one and the fourth one. So here's the third one. Here's the second one, taking square roots. Again, let's go back for a second to make sure it's clear. This is not always possible. We hope it is, but it's not always possible. Is this always possible? With effort, yes. I would use this method only if the setup is appropriate. What do I mean by the setup being appropriate? For example, if I have x squared equals 16, with factoring, we would have moved 16 to the other side. We would have factored into x plus 4 and x minus 4, set equal to 0, and then the solutions would have been plus or minus 4. But this is under the first method. This is the correct setup for taking square roots. What does that mean? It means that I will take the square root from the left-hand side and take the square root from the right-hand side. But remember, we are not told anything about x. So when I take the square root of x squared, what do I get? We even talked about this today.
X?
Never. It's the absolute value of x. If we're not told anything about x, the answer has to be the absolute value of x. The square root of x squared is the absolute value of x. The square root of x squared is the absolute value of x. If we know
the same question you were showing, I didn't put absolute value in the
yes
online. So
if x yes if x can be any real number or we have no indication, then we have to use the absolute value of x. So then this equation becomes the absolute value of x equals the square root of 16, which is 4. We normally skip this step. Why I'm showing this step to you is because the plus or minus, so this changes into positive x or negative x, set equal to 4. And then I have to multiply both sides by -1. So that's how I get the x equals plus or minus 4. I don't want you to think that the plus or minus are coming from the right-hand side. No. The square root of 16 is only 4. The plus or minus come from this side, from the absolute value. Why? Because positive 4 in absolute value is 4. Negative 4 in absolute value is also 4. Secondly, this is quadratic. If it's quadratic, we need 2 solutions. So we do skip this step. The reason I always show it the first time is because students say, oh, I know, the square root of 16 is plus or minus 4. No. The square root of 16 is not plus or minus 4. The 2 signs come from this side, not from this side. Okay, so here's another example. Let's say x plus 1 everything squared equals 9. Is this set up and ready for the square root? Yes. Yes. It's already set up. I will take the square root from both sides. I will not forget the plus or minus. I will not forget that the plus or minus come from this side, not from this side. And I will write that x plus 1 equals plus or minus 3. I should write this step. I should write the absolute value of x plus 1 equals 3, and then write this step and then this step. We skip this. We skipped it. Or I should write just we. We skipped this step. But this is the correct step. Of course, I have to move 1, but do not move 1 behind 3. Do not move 1 between the signs and 3. You have to move 1 right after the equal symbol. And of course, it becomes negative. So x equals -1 plus or minus 3. Because we can simplify, we have to write 2 solutions. They have to be written clearly. -1 plus, -1 minus. So, factoring, if it takes 20 seconds. If it takes more than 20 seconds, forget it. Taking square roots, yes, nice method, quick method, only if it's set up, if the equation is set up appropriately so that I can take the square root. Maybe move a term to the other side, maybe divide, but clearly ready for taking square roots. Otherwise, do not. Now, if you force me to, it's a different story. If you say you have to use this method, that's a different story. But so far, factoring, if it takes 20 seconds at the most. If it takes too long, I'll use a different method. Taking square roots, only when it's set up correctly. Or it's prepped, if you want. So here's another example. If I have 2x² minus 4 equals 5, you can say this is not prepped. Yeah, it's not. But it's a very easy step. Okay, so I have 2x² equals 9. I can take the square root. I have the square root of 2x equals plus or minus 3. I divide plus or minus 3 over the square root of 2. Or I can divide by 2 first and then take the square root. It's the same thing. So if it's effortless, meaning the equation is almost there, almost set up for taking square roots, then I will take square roots. Otherwise, no. Now, the third method is the method of completing the square. When will I use this in solving quadratic equations? Never. It's a very good method, but it doesn't solve the equation, and it requires employing the taking square roots as well. So then what's the use of it? Why is it here? It can be used to solve quadratic equations. Should we? No, unless you force me. If you say you have to solve this equation by completing the square, then I have no choice. But this method is a great method, but it's for something else. It's used in a totally different topic later on in math. Not too far out, quite soon. Not in this class. Here we learn it, and it can be applied to quadratic equations. Should we? Never. If you force me, I have no choice. So, what is the method all about? So let's take a look. Let's suppose I have x² minus 4x plus 4 equals 15. And let's suppose I am told you must solve this equation by completing the square. I say, oh, okay. First of all, I will move 4 to the other side. Allow me to not do that just this moment. I'll show you why. Normally we do, but not in this case. It's a very simple situation that I want to start with. Okay. When I look at the left-hand side, normally I would say move 15 to the other side and try to factor, etc., etc. There is no need. Why? Because I realize that the left-hand side can be easily factored. Into what? Well, it's a special product, so it's this. The first term squared minus 2 times the first times the second, plus the second term squared. So this was easy. And now I can take the square root. As you see, completing the square, I completed the square on the left-hand side. But completing the square does not solve the problem. It does not. After I completed the square, I have to take the square root. And yes, I have to write x minus 2 equals plus or minus the square root of 15. And we know that this is the square root of 15 and the plus or minus come from the other side. I have to move to right after the equal symbol. Do not write it between the signs and the square root or after the square root. And this is the final answer. And this time I will not split it because there is no need. I cannot simplify. What I want you to understand and remember is that Pearson will ask you to put these two with a comma. How do I put them? 2 plus the square root of 15, comma, 2 minus the square root of 15, in any order you want.